Alkaloids are natural limited-incidence compounds containing a nitrogen atom as part of the heterocycle. They are secondary metabolites, that is, compounds that are not directly involved in the growth, development or reproduction of organisms. They are found redent mainly in angiosperms and are much less frequently found in ferns and gymnosperms, or in bacteria, fungi and animals. They are biosynthetically derived from amino acids and usually occur in the form of soluble salts of organic acids. As a rule, they have basic properties in a pronounced pharmacological action. In different families of plants, usually only a few genera from alkaloids. Poppies or Poppies papaveraceae are an exception to this, since complex alkaloids occur in all genera. Garden poppy or Papaver somniferum contains white jelly in the mammary glands of unripe heads, which hardens when exposed to the air into a brown resinous substance, opium. Opium consists of alkaloids, organic acids, rubber, gum, lipids, resins, minerals and water. It is traditionally obtained by incision into immature poppy heads. For a long time, opium was the main source of poppy alkaloids, but this type of time-consuming extraction was replaced by the extraction of alkaloids from poppy straw or already ripe poppy heads. Many alkaloids and their semi-synthetic compounds are used for medicinal purposes. Garden poppy contains more than 40 different alkaloids. These include, for example, morphine, which is a powerful analgesic agent, cough-suppressing codeine, and papaverine, which acts against smooth muscle spasms. This laboratory exercise presents the model isolation and identification of alkaloids from heterogeneous plant material. Pure fractions of alkaloids are obtained by the shown multi-stage extraction. A simplified procedure with one-stage extraction will suffice to perform this exercise. The extraction of alkaloids will be performed in a glass column, where the activated silica gel will be used as a stationary phase and ethyl acetate as a mobile phase. We will exploit the ability of alkaloids to exist in a basic environment in a non-ionized form that is soluble in non-polar solvents. In an acidic environment, alkaloids would be in a form with a positive charge and would be soluble in polar solvents such as water. All polar compounds in this process will remain bound to the polar stationary phase in the column. Due to the single-stage extraction, the alkaloids will not be completely pure. In addition to alkaloids, some non-polar impurities will be present in the ethyl acetate extract, such as plant dyes, but this will not interfere with the subsequent detection of alkaloid. The plant material for extracting alkaloids is dried poppy heads, which are a byproduct of extracting poppy seeds for consumption. To perform column chromatography, weigh and mix in mortar 2 grams of powdered poppy capsules, 1 milliliter saturated sodium carbonate solution, and 3 grams of deactivated silica gel. Put a piece of cotton wool on the bottom of the glass column to prevent the stationary phase particles from leaking out of the column. Then add to the column a previously prepared mixture of ground poppy heads, sodium carbonate and silica gel. Another piece of cotton wool is added to the top of the column to prevent the stationary phase from rising when rinsed with the mobile phase. Transfer the prepared column to a fume hood and clamp it in a stand. In a fume hood, we measure 50 milliliters of the mobile phase, which in our case is ethyl acetate. We begin to pour the mobile phase into the column. Here it is important that the valve of the column is fully open and allows air to escape. When the mobile phase begins to drip out of the column, close the valve, if necessary, to achieve a flow rate of about 1 drop per second. When all the mobile phase has passed through the column, place the extract in a ground glass flask and transfer the sample to a rotary evaporator, which evaporates the solvent from the sample using reduced air pressure and elevated temperature. Solvent vapors are condensed using a refrigerator and collected in a separate flask. The procedure allows us to concentrate the sample. The vacuum and temperatures we use depend on the solvent we want to remove. In our case, the conditions are 60 degrees Celsius in 350 millibars. The alkaloids are detected using thin-layer chromatography, also referred to as TLC. More modern chromatographic methods, such as high-performance liquid chromatography or HPLC, could also be used, but thin-layer chromatography is a good choice due to its quick and easy execution and the presentation of results. TLC is a simple chromatographic technique used to identify compounds, check their purity or monitor the course of chemical reactions in synthesis. It is significantly faster than column chromatography, but much less sample is needed. Chromatographic separation takes place on a stationary phase, which is usually a thin layer of silica gel, SiO2, alumina, Al2O3, or cellulose. The stationary stage is applied to a tile made of an inert bracket. The mobile phase, which is typically a mixture of organic solvents, travels through the chromatographic plate by capillary traction, separating the compounds in the sample based on differences in adsorption to stationary phase in mobile phases solubilities. The sample solution is applied to the chromatographic plate manually with glass capillaries, while special automatic applicators are also available for quantitative work. Deposits are point in manual application or line deposits in automatic application. Along the edge, use a pencil to mark the line of application. The tile is developed immersed in the mobile phase in special developer tubes with a lid. In doing so, we take care that the mobile phase reaches below the starting line. The bathtub also contains a piece of filter paper that is soaked with the mobile phase and ensures that the atmosphere in the bathtub is saturated. When we observe that the solvent front reaches the mark for the front at the top of the tile is removed from the top and the level of the front is marked and dried. In the exercise we will use an automatic applicator, which gives better resolution and repeatability after developing patterns. First, apply the alkaloid standards of morphine, codeine, papaverine and narcotin to the chromatographic plate, and then apply concentrated extracts of poppy heads. The automatic applicator sprays the samples onto the plate while at the same time drying them with the help of propellant in the cylinder. The plate is then inserted into the chromatographic tank and developed. The mobile phase consists of ethyl acetate, toluene and diethylamine. When the mobile phase reaches the small upper edge, mark the front and dry the tile. Make the alkaloids on the plate visible by immersing the plate in a solution of potassium iodine bismutate called Dragendorf reagent. It colors tertiary amines red. Alkaloids are tertiary amines due to the amine group and will stain. After painting, the tile is dried. The colored spots in the extract samples are expected to meet the spots of alkaloid standards. We can conclude from this that all 4 alkaloids are present in our sample. Some additional spots are observed in the sample and are the result of other alkaloids such as thebaine. For individual alkaloids, retention factors are calculated by dividing the path distance of each spot by the distance of the mobile phase on the tile. The values of retention factors are between 0 and 1. The correspondence of the retention factors of the spots in the extracted sample and the spots of the standards indicate the presence of these alkaloids in the sample of poppy heads.